Welcome back, everyone! I am super excited to jump right into today's explainer. We're looking at a brand new, absolutely groundbreaking paper recently submitted to Hugging Face by the researchers over at SJTU Dang Lab. It represents a massive leap forward in mobile AI video generation, focusing on a brand new framework they're calling CineMobile. Okay, let's dive right into this. Just imagine, for a second, having the full power of a top-tier cinematic studio literally sitting right in your pocket. We are talking about taking a simple image and, directly on your smartphone, generating a professional-grade video sequence from it. No cloud servers doing the heavy lifting, no crazy internet bandwidth requirements, just pure, on-device creative power.
To demystify how these researchers are shrinking massive AI models down to mobile size, we're going to take 5 structured steps today. 1. The Mobile Video Challenge. 2. Introducing CineMobile. 3. The 3-step optimization. 4. Breaking the speed barrier. And 5. The future of creators.
Let's start with Section 1, the Mobile Video Challenge and the Mobile AI Hurdle. To really appreciate what these researchers pulled off, we first need to look at the huge roadblock facing developers and creators right now when it comes to mobile video creation. There's this massive growing demand to generate high-end cinematic motion effects natively on our phones. Creators don't just want basic little animations anymore. They desperately want to pull off specific, complex effects. Think of the iconic bullet time from The Matrix, the dizzying dolly zoom popularized by Hitchcock, or crystal-clear slow motion. And they want to do this on the fly, wherever they are.
But here is the core conflict. On one hand, we have the current state-of-the-art AI technology, diffusion transformers, or DITEs. Now, these are incredibly powerful for video generation, but they are heavy. They have massive parameter sizes and require multi-step iterative denoising. Basically, they have to do complex math over and over and over again just to clear up the image. And on the other hand, well, we have your smartphone. Mobile devices obviously have strict physical limits when it comes to computational overhead, battery life, and memory. The two just don't mix well at all.
That brings us to Section 2, introducing CineMobile and bridging the gap.
So the researchers set out to build a bridge across this exact hardware gap. Enter CineMobile. It's essentially a framework designed from the ground up to take those massive diffusion transformer capabilities and make them run on everyday mobile hardware. It's built specifically to enable efficient on-device image-to-video generation without needing to offload all that heavy math to a remote computer. But how in the world do you fit all that power into a phone?
That takes us to Section 3, the 3-step optimization, shrinking the model.
Let's move to the mechanics and see how this builds, because it's a bit like trying to smartly pack a giant overflowing suitcase down into a sleek, lightweight backpack without leaving any of your essential outfits behind. The team did this through a really distinct 3-fold optimization strategy. They kicked things off with distillation-guided pruning, followed it up with a mix of diffusion distillation and reinforcement learning, and then capped it all off with hybrid post-training quantization. Let's break these down one by one so we really grasp the genius here.
Step 1 is distillation-guided pruning. Now, pruning in AI is exactly what it sounds like. It's a lot like pruning a tree. You're systematically stripping away the unnecessary weights, the dead branches of the neural network. By letting the original massive model guide this process, that's the distillation part, they derived a highly compact, efficient model that somehow still manages to retain the core magic needed to generate those beautiful cinematic camera effects.
Okay, once they had a pruned model, they moved to Step 2. Here, they used a combination of diffusion, distillation, and reinforcement learning. Remember earlier when we said traditional models use that multi-step, iterative denoising that just takes forever? Well, this step drastically reduces the number of steps the AI actually needs to take to get the job done. They managed to optimize this newly compressed model down into just a 4-step generator, saving massive amounts of processing time.
And finally, Step 3 is hybrid post-training quantization. Think of quantization as the final squeeze. It essentially reduces the precision of the actual numbers the AI uses to do its math, which drastically shrinks the file size. Through this strategy, the researchers managed to compress the total model footprint down to under 1 gigabyte. This is absolutely crucial because it means the entire AI model can comfortably sit right inside your phone's memory.
Moving into Section 4, breaking the speed barrier and performance data.
So, we've got the theory and the methodology, but to prove CineMobile actually works, the researchers needed a solid baseline. They compared CineMobile's performance against its massive teacher model, which was built on the highly capable WAN 2.1 architecture. They basically wanted to see how the student compared to the master.
And the crucial point is this incredible metric, a 40x speedup. Compared to that original heavy teacher model, CineMobile achieves a staggering 40 times acceleration in generation time. But you know what the most impressive part is? It does this while maintaining comparable visual quality. You literally aren't sacrificing the look of the video just for the sake of speed.
Let's break down the real-world benchmarking. The researchers tested generating 49-frame videos at a 480p resolution. Now, on a massive data center-grade NVIDIA H200 GPU, the per-step denoising latency was lightning fast at just 0.6 seconds. But the true test is the mobile platform, right? On a mobile MediaTek Dimensity 8400 Ultimate 5G chip, it took 20 seconds per step. That means high-quality, 49-frame video generation is happening completely natively on a mobile processor in a matter of a minute or two. And here is the final knockout stat to round out the technical data. During this entire on-device generation, the peak memory usage was only 1.8 gigabytes. To put that into perspective, most modern smartphones today ship with 8 to 12 gigabytes of RAM. So an AI process peaking at just 1.8 gigs is amazingly efficient. It operates well within modern smartphone limits without freezing up your device or crashing all your other apps. Which brings us to our final section, number 5, the future of creators, democratizing AI.
We've seen the hardware gap, we've seen the three-step solution, and the benchmark data. Now let's talk about why this matters for you. We are witnessing a fundamental shift in how we create content. These researchers have proven the practical applicability of mobile-based image-to-video creation. This isn't just theory anymore. We are looking at a very near future where anyone can create complex, cinematic video art directly from their phone, completely untethered from massive desktop computers or expensive cloud subscriptions.
It's a real game changer. It is the ultimate democratization of Hollywood-level AI. The massive barriers to high-end cinematic creation are literally being shrunk down to less than a gigabyte and placed directly in your hands. Which leaves us with one final super exciting question as we wrap up this explainer. With the technical barriers completely removed, how will you use these pocket-sized cinematic tools to tell your next story? Thank you so much for learning with me today, and keep exploring.